So when I was a naive fourth-year graduate student in the year 2015, on the 14th of September that year, humans picked up something from space that was going to change the history of astrophysics forever. No, I'm not talking about contacting aliens, but something almost equally good. Two black holes were seen to spiral around each other and collide about 1.3 billion light years away from Earth. At that time, however, multicellular organisms were just about to be formed on Earth. Now, the collision of the black holes created ripples in the space-time around them called gravitational waves, as predicted by Einstein's theory of general relativity about 100 years ago. So these waves continued to propagate through space-time towards Earth for all of those 1.3 billion years, and were finally picked up by humans, the intelligent species that had evolved on Earth by then. Now, this was made possible because of detectors called LIGO, which stands for Laser Interferometer Gravitational Wave Observatory. These instruments work on the principle of interfering laser beams, where a small shift in the phase of the lasers due to a passing gravitational wave is what is recorded as an electrical signal. Now, the fact is that these instruments are terrestrial, and hence they are exposed to a lot of different noise sources, beginning from earthquakes to tumbleweed, and this leads to a lot of difficulty in separating signal from noise, and gives rise to a whole new field called data analysis, which is what I have been contributing to for most of my PhD. This is work that requires a lot of computational skills, mathematical skills, knowledge of physics, and of course, patience. In fact, the entire field of gravitational wave detection and analysis at present requires a 200-scientist-strong collaboration spread all over the world, which is what I am a part of, and a future network of 5 detectors, out of which only 3 are currently operational. And all of this has paid off very well, because the 3 founding members of LIGO were presented the Nobel Prize for Physics in the year 2017 for discovering gravitational waves for the very first time. And this enables me to say that I have been fortunate enough to be able to contribute to work that led to a Nobel Prize in the field, all during my PhD. But the work of LIGO did not stop there. LIGO went on to detect gravitational waves from colliding black holes many more times, and also a pair of very dense stars called neutron stars in recent times, which is an important event because that was also picked up by astronomers with their telescopes, thereby further corroborating it. At last, I would like to say that I like to think of gravitational waves as some sort of a message in a bottle left by long ago distant stars, so that human beings can pick them up and unravel stories about the lives of the stars, their origin and evolution, the evolution of the universe, and finally, this enables us to answer the very important question of where did we all come from? Thank you.